here it absorbs. And vegetation is, this is how we see the vegetation as green. If it is a healthy vegetation, then comes this particular part, which is very important for us as far as the remote sensing is concerned. Because at near infrared point, the red and near infrared point, it reflects. This is exactly what we see from the plant. So this is what we detect, and then we say, look, this is vegetation. I can simply say like binary A, GO1. Or you want to know vegetation, whether it is such and such crop. Is it forest or agriculture? Or is it under agriculture, what type of crop? Okay, then what is this condition of the crop? So those things one can get through this particular one to understand how healthy and how unhealthy the plant is. That's exactly what is the basic thing, even in the dream, as a remote sensing person, you should know. And that's how the various features behave in this electromagnetic spectrum. Now, I'm sure he's going to give more on this, but I'm just trying to give you two things one can do. One of the important resolutions as far as the remote sensing is concerned is the spectral resolution, apart from spatial, I'm saying that. How good is, you are able to get the information of the object, on the object. That's the spatial, right? The spectral is the one. For example, if I take a multispectral one, I have the satellite which gives me up to far infrared, near infrared. Different augmented satellites give you information on different spectra. So let's imagine this spectrum you have it. You have a discretion here. Blue, green, red, near infrared, far infrared, or whatever it is. It's very discrete. If I say blue is 0.4 to 0.5 in the electromagnetic spectrum, it's 0.6 to 0.7 or 0.7 to 1.1 is my near infrared. And beyond that is far infrared. I'm sure you remember your school days where the electromagnetic spectrum was studied. That's the multispectral one. Now people talk about these days the hyperspectrum. The main difference is a continuous one. I'm sure Rahul is going to give more yarn on this, but I'm just trying to cover this one. You get a continuous spectrum. That's because you have number of bands. You have only 5 here.